Welcome back. We're working on section 20.9 of the Klein's Organic Chemistry 2nd edition textbook. We want to deal with hydrogen nucleophiles. And here again, the chapter focuses on aldehydes and ketones. So let's just look at aldehydes and ketones. If you have a ketone, this ketone can be converted to a secondary alcohol with either lithium aluminum hydride or sodium borohydride. Sodium borohydride would be a one-step procedure. Sodium borohydride is a much milder reducing agent, and it hydrolyzes very slowly. It reacts with methanol very slowly, so we can actually do this in methanol as a solvent, and that's the proton source. Okay, so you can choose your reagent there. Okay, so it doesn't matter what ketone you have. It could be, in this case, 3-pentanone. Now, lithium aluminum hydride is sometimes abbreviated LAH, especially in the Klein's Organic Chemistry textbook. Okay, the book might write H3O plus or H2O, and this will make an alcohol. All right, so that's all you really have to write there. Aldehydes work in the same way. So, for example, if we have an aldehyde and we treat this with lithium aluminum hydride, and then in step 2 add water, we can form a primary alcohol. Now it looks kind of weird how it's drawn because we're not writing in this hydrogen that's attached to this carbon right here in this product, but that's a CH2 group, right? That forms from the original hydrogen, and then a hydride or hydrogen that's being added from the reagent. We'll look at the mechanism and you'll see where that hydrogen comes from and how this transformation works. So if you see this transformation, don't get confused by where the H's seems to have disappeared. We just don't draw the hydrogens attached to carbons in ordinary molecules, but we do for aldehydes. Okay, we can also do the same thing. The reduction can also work just fine with sodium borohydride and methanol. Okay. Now you might be wondering, well, since these two reagents do exactly the same thing, is there a difference? Yes, remember lithium aluminum hydride can react with any carbonyl containing substance. We'll see later on in subsequent chapters, it reacts with nitriles, it reacts with esters and hydrides, things like that. We've seen before how LAH or lithium aluminum hydride will react with epoxides. So if you want a milder reducing agent that will selectively and only react with your ketones or aldehydes, use sodium borohydride. If you want to bomb the heck out of all of your carbonyls in your molecule, esters, including aldehydes and so on and so forth, then use lithium aluminum hydride. That will do the job, okay? So let's look at the mechanism here. It's a very simple mechanism. Let's just look at benzaldehyde, okay? And let's do sodium borohydride in methanol. And this is going to make something called benzyl alcohol. All right. So the curved arrow reaction mechanism, again, if you're in my class, you can just write a hydride, draw out a hydride. If your professor is kind of picky about things, then definitely use borohydride, you know, and draw your arrows coming from this BH bond. But here I'm just going to draw the hydride attacking, okay? And that's essentially the same mechanism you would use for LAH, right? Lithium aluminum hydride is simply just hydride. Hydride is hydrogen with a lone pair of electrons and a formal negative charge. And so what you get from this step is your alkoxide And here I will color code in the hydrogens here so you can see what's going on. So there's my CH2 group that I've made right there on that carbon, and I've got an alkoxide. And so now what's going to happen is you're going to protonate this with your solvent. In this case, it's methanol. So we want to draw out methanol as an alcohol. You know, draw the bond line structure that shows that OH bond. And the alkoxide is going to become protonated. Okay, I forgot to show the steps here. So the first step is hydride attacking. The second step is your alkoxide being protonated to give you the final product there. And we're not drawing the two hydrogens on this carbon. We keep it simple there in the product, okay? So LAH would be the same type of mechanism. We just use hydride again, and then in the second step we would use H2O instead of methanol, all right? Problem 31 in the textbook says predict the major products for each of the following reactions. So let me use my highlighter pen here, maybe change it to purple. I think I might be able to see it. So again, you identify the carbon-oxygen pi bond, and you want to recopy your molecule, but you just want to make sure that you have an alcohol at that position, okay? So nothing happens to the aromatic ring. All of these carbons stay connected, and we form an OH there. Now, I'm not going to get into the complexity of this. We don't need to, but that's a chiral alcohol, so you're going to form a racemic mixture of the R and the S, okay? In this next molecule, we have something that looks a lot like benzaldehyde. We would call this cyclohexane carbaldehyde, and we just want to copy that same molecule out, but instead of the carbon-oxygen double bond, we want to write a carbon-oxygen single bond. So it's going to look like this, a nice six-membered ring without any double bonds in it, and then we want to write a single bond to the OH. You can draw it going up, okay? And you don't need to add all the H's to all the C's. If you want, you could just draw them all in, but it takes too long for me to add them all everywhere, okay? So that's it. That's a primary alcohol, and this is a secondary alcohol, okay? So ketones make secondary alcohols. Aldehydes make primary alcohols. That's one way to check your work, all right? Here we have LAH, okay, so that stands for lithium, aluminum, hydride, and then water. So again, we want to identify where that carbon-oxygen pi bond is. We want to recopy the whole molecule, don't adjust anything, and you just want to draw an alcohol there. So that's a secondary alcohol that we're forming. Here we have a carbon-oxygen pi bond. This is a ketone, so we're going to form a secondary alcohol. And there's a six-membered ring on the left, and we have a four-membered ring on the right, and there's going to be an OH there going up on top. Okay, so that's the basics of this chapter. There's no more real detail that I can add based on previous chapters we've talked about when we talked about alcohols. So that's section 9. Thanks for watching, and stay tuned for further sections in this chapter.